in this video, we're going to go through an example where the first one is a multivariate hypergeometric distribution type question, and then the next several are relating to the singlevariate hypergeometric distribution. Okay, so let's go ahead and read through and see what's happening. So we have a company has 2 managers, okay, 4 human resources employees, 15 computer engineers. All right. An outside organization is interested in employee satisfaction within this company, and it decides to randomly select 5 employees to participate in a survey. So we notice right off the bat what's going on here. We are randomly selecting 5 employees from this group of, let's see, 15 plus 4 plus 2 is only 21 employees here. Okay, so we're selecting 5 from a group of 21. All right, and so we should be thinking hypergeometric distribution because we're going to be doing the selection without replacement. All right. So what is the probability that exactly 1 manager, 2 HR employees, and 2 computer engineers will be selected to participate in the study? All right. So I'm going to go ahead and do the subscript of 1 is the manager. All right. The subscript 2 is going to be the HR. And the subscript 3 is going to be the computer engineer. Okay. So this question is asking, what's the probability that X1, okay, the number of managers selected, X1, equals 1, okay, and the number of HR employees, X2, what's the probability that that equals 2, and what's the probability that X3 equals 2 as well, right? 2 engineers, that's X3. 2 HR, that's X2. 1 manager, that's X1. All right, so we want to figure out what this probability is. The probability that the number of managers selected is 1, number of HR employees is 2, and number of computer engineers is 2. All right, so to do this, we're going to use the multivariate hypergeometric distribution. So we have 2 possible managers, and we are only selecting 1 of them. We have 4 HR employees, and we are selecting 2 of them. We have 15 computer engineers, and we are selecting 2 of them. All of that divided by capital N, right? Total number of people here in this small population. We have 21 people, and we are choosing 5 of them. All right. So there you go. That would be using the multivariate hypergeometric distribution to solve this. All right. So now what's the probability that out of the 5 randomly selected participants, at least 1 will be HR? Okay. So at this point, we're only talking about HR. So really, we only care about X2. We are not going to be talking about X1 and X3 in this problem. That's what makes this a single variate hypergeometric type problem. Okay, so what do we want to know? We want to know what's the probability that at least 1 HR. So that means X2 is greater than or equal to 1. All right, so that means X2, so the number of HR employees, it could be 1. How many HR employees are there? Total, there are 4. So it could be 1, 2, 3, or 4. Right? And that takes a long time. We could add up all those different probabilities. The easier way to do this is to use the complement. Okay, we're seeing at least 1 here. So whenever you see at least 1, always think, well, what's the complement? It's none. So that would mean the probability that X2 equals 0. Right? At least 1 minus probability of none. Right? Okay, so let's see, how would I calculate this probability of none, right? So using the single variate hypergeometric distribution, I have 4 HR people. I'm selecting 0 of them. Okay, left over in my population, I have 17, right? 21 minus 4. Or in other words, I have the 15 and the the 2, right? 15 computer engineers and 2 managers, right? So I have the 17 and I'm choosing 5, right? And then that divided by the 21 choosing 5. Okay, that would be how we solve that one. Okay, so now let's see how many HR employees are expected is a keyword, to be selected for the survey. So basically what I'm trying to find now is what's the expected value of X2. So if you know X2 is hypergeometric distribution, then you should know that the expected value of a hypermetric distribution is n times p. Okay, here n is your sample size. So how many am I selecting? I'm selecting 5. And p is the probability of success for that x, right? So the probability of getting a HR employee. Well, there are 4 HR employees out of the 21 different employees. So 5 times 4 divided by 21, if you calculate that, you should get 20 over 21, right? Or approximately 0.9524, something like that. Okay? So we would expect to get, on average, a little less than 1 HR employee if you randomly selected from this population. All right, now how would we calculate the variance for the number of HR employees? Again, we know X2. Now the number of HR employees is X2. We know that this is a hypergeometric distribution, so we have a formula for that, for variance. Oops, I wrote expected value. Let me correct that. For the variance, right? So it's capital N minus N over N minus 1 times N P Q, right? This little piece over here is the variance for the binomial distribution, and this is like some sort of correction for the fact that you are sampling without replacement. Okay, so we just need to know what each of these pieces are, and we can calculate this. So let's see, capital N, total number of people in this population. Well, there's 21 employees. Little n, number of people that are being selected. There's 5. Okay, capital N is 21 minus 1. Okay, so there we go. Little n is 5. P is 4 over 21. We just talked about that. And what's Q? Q is 1 minus P, right? So that would be 17 over 21. All right, so if you calculate this, you get, let's see, 16 over 20 times 20. I'm doing the 5 times 4. 20 over 21 times 17 over 21. It's a little bit of cancellation. You should get 272 divided by 441. Okay, and that's the variance for the number of HR employees that would be selected.